all of these rooms have purposes. The airflow works in a certain way so that it complements the workflow. And then the machines, as they get arranged in this room, are actually doing certain things too. So we've got Matthew and Ryan. These guys know everything about the facility because they're part of it. So I'm going to be giving away a presentation. Blair, if I say something wrong, just pretend that it's right, please. No. So getting back to it, if it looks a bit like a dance floor now with lots of space, it's because it was actually designed for some expansion. And all of the equipment that will ultimately be in here one day, we can't imagine. But even as we start to approximate it, much more of this will be filled by different things. So let's go this way. I don't want to talk over Sonia, so we'll actually go over this way. Before we go in the second part, though, what I'll point out is that in addition to the equipment in the rooms and how they're laid out with the robots, there's also personnel embedded within them. So unlike a lot of other areas where you come in and you just use these things, here you can't really walk up and use these things. So you need people who are especially trained to do it. The manager, James Gray, is actually because this is a specialized thing. And here will be for data analysis. There's a lot of it that comes down the pipe. So come on in here. So what happens after you put together, in theory, an experiment that you're going to interfere with an important gene, or better yet, hundreds, or better yet, thousands of genes, in order to change the biology, to change how the disease process is working? What comes next? Analysis. In other words, you're going to go back and look at the differences in the system to see what you've done and how it's affected things. So in this part, this room has been built and set up to house genome scale sequencers. So what are called next generation sequencers. And these can do entire genomes. They can do it very quickly. And already, as kind of a demonstration of how the technology works, just here we have essentially two different ways to do it. So Brian might tell you that this is the best way to do it. But objectively, there are different ways to do it. And we recognize that in every couple of years, you're actually going to be chasing this technology. And that's a good thing, because this has essentially levered off of technology what we can do in science. So just as kind of an interesting, to me, kind of a physical demonstration, this and this try and do the same thing. They both sequence DNA. Very different ways of doing it, but you can see that the form is evolving. Over here is, instead of looking at the changes in terms of the genetic material, this is looking at the changes in the physical, outside, inside, or spatial differences between cells. So this is kind of a mainstay of immunology. It's called a flow cytometer. Whereas over there, I told you about how you can do this massive sequencing and look at the changes genetically. This machine is built to very quickly cycle millions of cells through. They pass by lasers, and they can detect with extreme precision on a cell-by-cell basis what's different and what's the same about cells. And it's really millions, tens of millions. And that's very powerful because now you can actually start to take apart this interaction. I mean, after all, the immune system is not any one thing. It's a series of cells and interactions. Across over here, what you see on the screen flashing are essentially microscopy images. So what you might see looking down the fluorescent microscope. But what's different about this is that it can do it very quickly. And there's software that, in the hands of trained people, can make semi-intelligent decisions. In other words, if a cell is close to another cell and it's expressing a certain phenotype, it's acting a certain way, highlight it and count it and tell me how many times it happens. So what I hope that you'll take away, actually I have one last thing, but what I hope you'll take away is that all of this, everything from the way the facility is laid out, to the instruments, to the people, to everything, is built so that we can do what we do very fast, in massive repetition, and massively parallelized. And so what you don't see in here is about 100 terabytes currently of storage. That number will go very high. but in another room, a giant computer cluster for storage. This information is essentially the binary equivalent of biology, and it's massive. And it's at that point where I think a lot of magic happens. It's actually where scientists like Matt or Ryan get to see what their hypothesis is actually manifest in terms of data and what it means. And so, actually with that, I'm going to turn you over to Sony. She's going to talk about a couple of other things too, in particular what we're doing.
So Steve, there's enough equipment here already to do all the RNA testing?
There is.
But there's more equipment coming.
Yeah, so this is, we built out enough space so that as we ramp up and do more things, we can fit it. But yeah, off the ground, I mean, that initial grant gets us started. But this is very scalable. This is the kind of thing that the more of this we have, the more of it we can do. A lot of it's actually limited by the number of people and the cost of those supplies. There's an underlying cost there. After that,
and is it Illumina as a new sequencer?
Yep.
And are we buying those?
I don't know. I don't really think so.
Right, for like technology. I would say I made the right choice.
Yeah.
So the 5500 is actually our newest sequencer, as well as new technology, ion torrent. So you're actually both of our.
Got a lot of publicity recently.
Exactly.
The cost of the equipment.
Oh yeah, no. Actually, in the seminar today, Lee Hood, who is extremely credible since he invented the technique, he predicted that there would be multiple $100 genomes, which implicitly means that the equipment or the reagents or something gets a lot cheaper, a lot smaller, a lot faster in a couple of years. So I can't wait. We're going to back with this. Yeah. So no, actually we have. I mean, to do a genome for 4,000 or 5,000 is still lots cheaper than it was just a few years ago. So, after the tour, you guys are welcome to look around as well.